students, today in this lecture we will study the fourth and last chemical property of ethers, that is electrophilic substitution in aromatic ethers. Aromatic ethers means ethers in which oxygen atom is bonded to two aryl groups or one alkyl group and one aryl group. Now you know the meaning of electrophilic substitution. The reactions in which hydrogen atom at ortho and para position is replaced by electrophile, that is electron dependent species, are known as electrophilic substitution reactions. Now in case of electrophilic substitution reactions of aromatic ethers, the products are ortho and para derivatives, not meta derivatives. See what is the reason? See here, this is the in general aromatic ether. This is benzene ring. Okay, and here there is O and here there is R. So this is alkyl group, this is aryl group or benzene ring, and this is O. Means what? It is a alkyl aryl ether. So it is known as a aromatic ether. Now you know the atomic number of oxygen is 8 and electronic configuration is, say this is O8, 1s2, then 2s2, 2px2, 2py1 and 2pz1. Now if we see the electronic configuration, then there are two shells. So second shell is outermost shell, and in outermost shell there are 6 electrons, 2 single electrons and 2 pairs. Now these 2 single electrons, one in 2py and one in 2pz, forms covalent bond with carbon in alkyl group and carbon in benzene ring. And now there are these 2 pairs, one in 2px and one in 2s. So these pairs are not used for bonding, which are used known as non-bonding electrons, unused electrons, delocalized electrons or lone pair electrons. So these are the 2 electron pairs. Okay. Now these electrons are in conjugation with pi electrons of the benzene ring, or they delocalized over this benzene ring, and that is known as a resonance effect. So this alkox group, R means alkyl group and OR means alkox group. This alkox group has a positive resonance effect, which is known as a plus R effect. Now same thing we studied in the phenols also, how delocalization takes place. I will repeat once again here. Due to delocalization of this electron, one of the 2 electron pairs, there are different structures. So here, if this pair comes here, then this pair comes here. So see what is the structure here. Okay, now here there is a double bond, O and R. Okay, and now there is only one pair, and now these 2 electrons are of oxygen before delocalization. Now when this pair comes here to form a double bond, then both electrons not belongs to oxygen, one belongs to carbon, one belongs to oxygen. Means what? Indirectly oxygen lost its one electron, and therefore there is a positive charge on the oxygen. Now if this pair remains as it is, then there will be 5 bonds of this carbon, 2, 3, 4 and 5, and therefore to maintain the tetravalency, this pair comes here, means what? There is a negative charge, and remaining 2 pairs double bonds are as it is here and here. Now what happens here again? This pair comes here and therefore this pair comes here. The third structure is, so here there is a double bond, here there is a negative charge, again here there is a double bond, here double bond O R and one pair and one positive charge. Okay, now this pair comes here, and therefore this pair goes here. So structure is here double bond OR, then here there is a double bond, here there is a double bond, and here there is a negative charge, and here two negative charges and one positive charge here. No, two electrons and one positive charge. And last this comes here and this goes as it is here, and there are final structure is here. One more. Now there is single bond O R, and now there are two pairs, and therefore there is no positive charge. So as in first structure, and here there is a double bond, here there is double bond, and here there is double bond. So there are 5 resonance structures of aromatic ether. Now if we see middle 3 structures, then there is negative charge at ortho and para position. So these are ortho positions, this is para position. So here, here and here. Means what? Due to plus R effect, electron density at ortho and para position increases, but there is no change in the electron density at meta position. And as electrophiles are electron different species, they will easily attack at ortho and para position, not at meta position. And therefore, in these electrophilic substitute reactions of aromatic ethers, the products are ortho and para derivatives. Now there are only 3 reactions which are similar to that we studied in phenols as well as in haloarenes. So see one by one. So first is a halogenation. Now you know the meaning of halogenation. The substitution of hydrogen atom at ortho and para position by halogen is known as a halogenation. Now here see example. Here example is, this is benzene ring. Now here there is O and CH3. Now here this is methyl group, this is phenyl group. Therefore common name of this compound is methyl phenyl ether, and IUPAC name is this is a methoxy group, OCH3, methoxybenzene. So I will write here. And there is one more name of this compound, that is known as anisole. Now here there are 3 names of this compound: methyl phenyl ether, or methoxybenzene, or anisole. Now when this is treated with bromine, which is a halogen, in acetic acid CH3, this is the formula of acetic acid, then a mixture of ortho and para derivatives formed. So here there is double bond. Now here OCH3 as it is. Hydrogen atom at ortho position is replaced, and plus in some molecules the hydrogen atom at para position is replaced. Now here there is a now balance reactions are not given. Now what is the name of this compound? This is ortho, then bromo and anisole. And what is the name of this compound? This is para position. So P bromo anisole. Now here this will obtain only 10%, and this is 90%. Or this is a major product, this is minor product. This is due to the steric hindrance of methoxy group. Now this is a halogenation reaction. Okay. Now second is Friedel-Crafts reaction. F-R-I-D-E-L. Friedel-Crafts reaction. The substitution of hydrogen atom at ortho or para position by alkyl group or acyl group is known as a Friedel-Crafts reaction. There are two sub-reactions. First, when this anisole is treated with alkyl halide, for example methyl chloride, then ortho and para derivatives are formed. To see what is the reaction here. here OCH3, this is anisole, plus methyl chloride. What is the formula? CH3Cl, and this reaction takes place in presence of anhydrous, means dry aluminum chloride, AlCl3. Now as usual here, hydrogen atom at orthon para position are replaced by CH3 group. So here OCH3, here there is CH3, okay, and plus again here OCH3, and here not here, here this CH3. You see what is the name of this compound? This is known as a toluene. Okay, if there is a no this group, then this is a toluene. So with respect to this is second position, and this is a 1 2 3 4 4. So its name is what is here? This is methox group. So 2-methoxy, METHOXY, methoxy toluene is the name of this compound, and here with respect to this is fourth position. So 4-methoxy toluene is the name of this compound. Now here this is again, here this is also a minor product, this is a major product, means what this molecule form more. Now if this anisole here is treated with OCH3, this is anisole, treated with acyl chloride, for example acetyl chloride, CH3COCl, in presence of this AlCl3 anhydrous, then hydrogen atom at orthon para position replaced by this CH3CO. So this is benzene ring. OCH3, and here there is COCH3. Now replace H, and this will form HCl byproduct. So here plus OCH3, and here there is a COCH3. Now this compound is known as a acetophenol. This is ketone. Here function with CO, RCOAR. So this is ketone, and its name is acetophenol. Now from here if we start numbering, then this is second position, this is a fourth position. So name of this compound is a 2-methoxy acetophenol, and this is a 4-methoxy acetophenol. So this is these two reactions are known as a Fiedel-Crafts reaction. Now there is only one reaction, third, that is nitration. The substitution or replacement of hydrogen atom at ortho or para position by NO2 group is known as a nitration. Now when anisole is treated with nitric mixture, that is mixture of concentrated nitric acid and concentrated sulfuric acid, gives a mixture of orthonitrophenol, here first reactions. This is anisole OCH3 plus, not plus here, you can write on the here also concentrated H2, which means nitric acid, and concentrated sulfuric acid H2SO4. This is anisole. So here one ortho derivative OCH3, here there is a NO2, and in second molecule there is nitro at para position. Now this is a orthonitro anisole, this is a paranitro anisole. So these are the three reactions of aromatic ethers. And last point is uses or applications of ethers. There are only two uses. First, earlier diethyl ether was used as anesthetic in surgical operations. And second, diethyl ether is usually solved for Grignard reagent reactions, fats, oils, waxes, etc. तर या ठिकाणी हा टॉपिक संपलेला आहे. ह्याच्या 3 रिॲक्शन्स आहेत. ह्या 3 रिॲक्शन्स या मी तुम्हाला दिलेले आहेत पूर्ण टॉपिकच्या थोडंसं वेळेमध्ये बघू आपण. तर हे आता मी सांगितलेलं आहे बघा, इलेक्ट्रोफिलिक सबस्टिट्यूशन्स इन ॲरोमॅटिक इथर्स. हे डिलोकलायझेशन दाखवलेलं आहे ह्या पद्धतीनं. आणि ह्या 3 रिॲक्शन्स आहेत. म्हणजे आपण जे आरेल हायलाइट्समध्ये जे फिनॉल्समध्ये भेटले तशाच टाईपचे आहेत. आर्थोन पॅरापोजिटला काय होतं, हे हायड्रोजन रिप्लेस होतात करस्पॉन्डिंग हॅलोजननं किंवा अल्किल ग्रुपनं, ॲसिडिक ग्रुपनं किंवा नायट्रो ग्रुपनं. हे आहे फ्रेडल क्राफ्ट रिॲक्शनची पहिली रिॲक्शन, ही दुसरी रिॲक्शन, आणि ही आहे नायट्रेशनची. हे 4 नायट्रोॲनिसोल किंवा इथून पॅरानायट्रोॲनिसोल लिहा, हे 2 नायट्रो किंवा आर्थोनायट्रोॲनिसोल लिहिलं तर चालतं. आणि शेवटी 2 युजेस. ह्या ठिकाणी हा टॉपिक संपलेला आहे. तर आतापर्यंत ऑर्गॅनिकचे 2 मोठे टॉपिक झालेले आहेत. तर तुम्ही त्याच्यावरचे जे एक्सरसाइज मी क्वेश्चन दिले ते दोन्ही टॉपिकचे क्वेश्चन्स बघा आणि क्वेश्चन्स आन्सर लिहून काढा. लिहिल्यानंतर तुमचं प्रॅक्टिस होईल. आणि त्याशिवाय मागल्या जे 2-3 एक्झाम आहेत बोर्डाच्या, त्याचे क्वेश्चन पेपर बघून त्या एक्झाममध्ये सुद्धा ह्या 2 टॉपिकवरचे जे क्वेश्चन्स दिलेले आहेत ते एकत्र करा, ते परत सॉल्व करा. म्हणजे तुम्हाला नेमके बोर्डामध्ये हे क्वेश्चन्स कसे विचारतात हे तुमच्या लक्षात येईल. आणि ऑर्गॅनिक केमिस्ट्री बाबतीत समजायला फारसं कठीण नसतं, पण सगळ्या रिॲक्शन्स आहेत. थेरॉटिकल पार्ट कमी आहे. थेरॉटिकल पार्ट एकदा समजला आणि एकदा लक्षात राहिला की सहज विसरत नाही. पण ह्या ज्या रिॲक्शन्स आहेत ह्या पुन्हा पुन्हा कराव्या लागतात. त्याचं रिपिटेशन आणि प्रॅक्टिस केल्याशिवाय त्या रिॲक्शन्स लक्षात राहत नाहीत. 1-2 दिवसाला ते रिपीट करावे लागतात. तर तुम्ही शॉर्ट नोट काढून जर रिॲक्शन लिहून काढल्या थोडक्यामध्ये सगळ्या, आणि त्या जर वारंवार बघत राहिला तर तुम्हाला काय होईल, ह्या रिॲक्शन्स पाठ होतील. काही शंका असतील तर तुम्ही फोन करू शकताय. नेक्स्ट लेक्चरपासून आपण नवीन टॉपिक चालू करणार आहोत. तो टॉपिक आहे 9वा टॉपिक, कोऑर्डिनेशन कंपाऊंड्स. त्याच्या काही नोट्स मी दिलेले आहेत आणि बाकी नोट्स आहेत त्या मी सायमल्टेनियसली लेक्चरच्या वेळी पाठवत राहीन. ठीक आहे, या ठिकाणी आपण थांबूया. धन्यवाद.